make it real. We appear to be verging on a crisis point right now with the first kind of trash, and we all know what I'm talking about here. But we fail to ever consider the second kind. We fail to consider where our digital ephemera is accumulating, and we never think about where our data is rotting away once we're done with its use. All the data that you have right now, whether that is years worth of photos or every assignment that you've ever completed, it's all accumulating on a centralized storage network. But let me tell you something. There's a lot wrong with them. In a centralized storage system, all data is stored in one location, making it so much more vulnerable to cyber attacks and hacking attempts. Centralized storages also have a very unique feature. They create a single point of failure. If the system goes down or experiences technical difficulties, all data stored on it becomes inaccessible. Pretty much, if this central system goes down for any reason or experiences technical difficulties, you won't have access to anything that you own indefinitely. And not even that. These centralized systems create so many limitations on who can access specific data and how it's used. And these limitations are rarely known to the users accessing the service. In other words, we have no idea what is happening to our data. And that is why my third build in Web3 was a very intentional one. I decided to completely clone a centralized storage service in a decentralized manner, enabling the same functionalities for a user, but with 10x security, assurance, and convenience, proving why the switch to a decentralized storage network is so worth it. Let's get a bit technical here. Decentralized storage systems use advanced encryption techniques, and they distribute data across all nodes. This is what makes them so secure and less vulnerable to hacking attempts and data breaches. Users also have so much more privacy now because they have complete control over their data and who they want to share it with. Plus, you can access this data from anywhere in the world because there's no server restricting it by location or access permissions. In direct contrast, and circling back to my earlier point, decentralized storage systems have no single point of failure. They're so much more resilient and they can withstand any outages, attacks, or other disruptions. I also mentioned giving access to other people. In a decentralized storage system, you can share files purely peer-to-peer and make sure that only the intended person can view and download the file. But what makes these differences? In traditional web protocols like HTTP, each file is addressed using location-based addressing. Pretty much each file is identified using a URL, a uniform resource locator, and this is what specifies its location on a central server. That's why it's so hard to locate that file or access it if the server or the URL is down or no longer to be found. HTTP downloads files one at a time, but peer-to-peer storage networks like IPFS retrieves pieces of your file from multiple nodes. This is what saves so much bandwidth as well. I've always learned best visually, and I'm always creating mental flowcharts when I'm working around with logic. So let's take a look at this visual here. There's a lot going on, but fundamentally, here's what happens when I upload a file to IPFS, which is the most basic function of my smart contract. I am this super cool dApp creator, and I create the front end and the back end with React and Solidity. I then compile all of my smart contracts using a framework like Truffle or Hardhat, and then I migrate or deploy them to a blockchain. When I want this application to be for real use, I'll deploy them to the Ethereum network, but right now I'm using this local blockchain called Ganache. I'll then enable MetaMask to connect to the blockchain via a Web3 provider, and I can now call the most basic function of my smart contract, which is to upload a file. So I'll run the dApp and I'll upload the file using React. This is what will publish it up to IPFS. And then IPFS, which is the decentralized storage network, will return a specific file hash for that file. The plan here is to get React to connect to the blockchain so that they can add this file hash to the smart contract. And this counts as a transaction because we're adding new contents to the smart contract and changing its state. So we'll go through the Web3 provider and the MetaMask extension to get this transaction approved. And then we can finally add that file hash to the smart contract. Finally, the only thing left here is for the user to view and download the file straight from IPFS using this specific file hash. And again, IPFS is that decentralized storage network. My other functions enable users to delete, share, rename, list, search, and organize their uploaded files into folders, enabling the most ideal and identical user experience for users that are currently using centralized systems. So that's why this smart contract has all the functions that I just outlined. But I also have a React frontend that I've mentioned multiple times. And this is what connects to the IPFS client and leverages all the tools that the network provides so that users can interact with the decentralized network. If you guys want more of a detailed run through for each of my functions, as well as my React frontend, be sure to check out my article that I'll link below. For example, the upload file and the delete file functions that you see over here and over here have two components, and they show up in the front end and the back end. This is because these are the only functions that need to interact with the data in IPFS for them to follow through. These are the types of details that I talk about in my article below, so be sure to check it out for a more technical overview. I just wanted to quickly hop on here and update you guys about my latest project. This is still definitely a work in progress, and I have a long way to go before I can make this an identical experience for all users. Either way, I'm super excited about this project and where it'll take me and all the discoveries that I'm going to make along the way. That's it for now. Bye, guys!